All right, let me resume. And one thing I just realized, I got a mistake over here. Dekat sini. Okay, this one I draw a bit wrongly already. You guys go and amend on your own. Because 8 already, 9, 10. Here should be, one moment. Here should be 11. Okay, so it should be something like A, okay, 0 to 3, and then B until 5th second, and then continue to A until 8 seconds. So over C, right, only 11. So at 11 second, our E is not here, right? So you continue with your donkey of 3 millisecond, right? Okay, 3 millisecond here. So you process it 11，然后滴的2秒12 13 so 13 done already. So over here it should continue with C because just now over here your E is not here yet. Okay, so we continue with the C of 1 millisecond. So we add until 14 and then only process the, is it right, until the last one, which is E, and E will goes up to 18 second. Yeah, I just realized over here I got a mistake. Okay, if this one cannot follow, okay, tomorrow night I'll try to schedule for okay, let me confirm with you again because I'm not sure it's possible to do that, but I'll try to schedule another sort of like revision with all of you. Okay, but that's for tomorrow night. Let's say tomorrow night. Okay, I'll try to schedule, and it's a little bit late because tomorrow I don't work on site. And for those that having early morning tests in Tuesday, I worry you cannot make it and you guys are having CC as well, right? Got computing. So yeah, so this is for the round robin. Let me just proceed with the next one, which is priority scheduling. So over here you can see I highlight this preemptive, right? Okay, this document we share to you okay, with answer and without answer both we share with you. You can just do it there. Okay, now for this one, do preemptive okay, and you assumed a larger priority, larger number. So which means in this case, right, E has the highest priority. Okay, so same. One moment, let me mute myself a while. Okay, now continue over here. So priority scheduling. Okay, we're going to do the preemptive one. So a higher priority value indicates more important. So now start from 0 again. Your Gantt chart, you only have process A coming in. So you're going to do process A, okay, for 1 millisecond, 2 millisecond, 3 millisecond. Okay, someone comes in at here, which is process B and having a CPU cycle of 2. And this time you got a priority of 2. Now you compare because higher, which means more important. 2 and 1, 2 is higher, right? So A have to wait. Okay. So at this point, definitely we are going to process with the B one. Okay. Now B execute for 1 millisecond and execute for 2 millisecond. All right, B is done. Okay. Excuse me. So now B is done, and don't forget at this 5th millisecond, 6 is not, I mean like C process is not here. You still left your A. Here already execute for 3 millisecond. So you left 3, right? So we continue with the A. Okay. Now execute for 1 millisecond, which is 6. Okay. Your C comes in with a CPU cycle of 4, priority of 3. So 1 versus 3, 3 is bigger. So this time A have to let, like A have to go somewhere, like go into the process control block store the data into that, and your CPU is going to execute C. Now execute for 1 millisecond, 7, 2 millisecond, 8, 3 millisecond, 9, 3 millisecond only at this point. Okay, you got a process D coming in already. Now D is 2 millisecond of CPU cycle, but the priority is 4. 4 is bigger than 3, right? C only have 3, a number of 3. D have 4. So even though C already execute for 7, 8, 9, 3 millisecond, even though execute for 3 millisecond and left 1 millisecond only, okay, you are going to let your CPU also. CPU is going to let process D because D have a higher priority. Okay, so bear in mind, just now B already done, so this one is already done. But our process A, right, we process for another 1 millisecond, so we have to deduct 1 over here. You left 2 millisecond. Okay, so now in the queue, you have A and C. Okay, but your CPU have to work on the process donkey because the highest priority over here. Okay, so now donkey for execute for 1 millisecond, 10, 2 millisecond, 11 millisecond, done. Okay, we're done with donkey. Okay, now at this point, look at here, your queue have process A and process C. Don't say who shorter, then I do who. You look at the priority. Who have the highest priority? C have the highest priority, which is 3. So that's why we continue with C, okay? And then for another 1 millisecond, okay? And our C is done as well. Okay, at 12 millisecond, our E comes in, process E comes in with CPU cycle of 4 and a priority of 5. Okay, CPU cycle of 4 and a priority of 5. So 5 and 1, definitely 5 have the higher priority. So your CPU is going to process the process E, okay, for 4 milliseconds. So we will process it until 16 milliseconds. And lastly, which is the lowest priority of 1, process A, having another 2 milliseconds, which is 18. So we are done in this case. Okay, so the line, you go and draw I have it here. Okay, so something like this. So that's all for the priority scheduling for preemptive lah. So non-preemptive, lower priority implies a higher priority. So then which means at that moment, 1 is greater. So at here, you will continue to just process A instead of switching to B. There's no process swapping lah if we are using the non-preemptive here. Okay, so that is the case. Any questions? Any question afterwards? Okay. For my students, if you have a group with me, you just go inside the group and liaise me lah. Okay, then we can look into any doubts you have. Now, I just continue proceed with this directed resource allocation graph. I know you think it is easy, okay? I know majority of you know how to draw already, but just to emphasize, please make sure in your exam you get enough sleep where the arrow you don't mess up. So okay, I just try to teach again lah. Two alphabet that you have to understand. One is the P, okay? Normally they will give you R as resource, but you see in this question, P is process. Okay, but you see in this question, the resource they give you A, they give you B, and C, okay? So the easiest way for us to differentiate, when you want to do process, you draw a circle. Alamak, my circle cacat. Okay, if you want to draw a process, you draw a circle. Inside, you put your process. So if it is process 1, you put like this. So if you want to draw resources, you do the square or we say the rectangle shape. Okay, depends on what you want to draw lah. Then you draw the A inside. Now, if they have mentioned that is instance, you just draw this button out lah. Okay, just that simple. This is resource. This is process. Okay, now look into the mapping. I believe I'm sharing this slide as well, right? Okay, so if the arrow, right, you draw from the arrow here, you draw from your process, this is process to the resource. Let's say this is the A, so this is the process 1. You draw it like this, which means you are requesting. Requesting, which means you don't own this process. You don't own this process, or you are not using this process, but you don't use this resource, or you are not owning this resource. Okay, you are just trying to request so that you are able to get these resources, but at the moment you don't own any of them. But if the arrow is on a reverse, right? Okay, map from the resource to the process, which means the process is actually using it already, holding it already in use. Okay, this resource is in use by this process. So the arrow, no matter what, you better go and check before you enter the exam hall again. Okay, so if we are drawing from here to here, like this is requesting. Okay, you don't own any resources. Okay, change one color. Let me do orange. Okay, now if you realize I actually prefer okay, or somehow like every time I draw holding I will based on this instance draw back to the process 1. So this is holding. Okay, for the orange color can differentiate, right? So the reason let me explain one more time. The reason why I do it like this, okay, actually you can do it this way as well. You draw from this big box to this, like this big box resources to this process. You can do this. There is no wrong, no mistake. But the reason I draw it from the instance up to here is so that I know exactly which thing is actually holding. Because if let's say there is 3 holding, or sometimes I mess up with the holding already because there's only 2 instances. What if I thought there is 3 or something? Okay, what if because if I just draw based on this box, I don't know exactly how many instances actually being held or being in use. So that's the reason I draw it over here outside. Okay, sorry, draw it inside. I mean, if you want to draw outside, yes, I won't deduct your mark on that. Okay, so make that clear. So with that being said, now you know process, and then you know these are holding and requesting, and then you know about resource already. Now every time you draw this thing, don't panic. Okay, I prefer doing something like this. I draw out first. There's 4 process, so I draw 4 process out. P1, P2, P3, and P4. Clear? Okay. Now there's only 3 resources, so I draw the resources out as well. So A, I got 2 instance, so 2 little dot. B, I got 1 instance. C also got 1 instance only, so I draw this out and then I put them into the box. Okay. I think this one is a bit hard for you to see, because I mean on this tools, right? It's a bit chat lah, my drawing. Okay. Now I try to use a light green color, okay, to do the connection. So every time you look at this question, you interpret this one first. This one done already, then you process with resource. You draw this out already. Keep calm, okay? Keep calm. Now try to understand one by one. Look into the first one. P1's hold an instance of A. Now holding, holding, which means like this. Okay, holding, from the resource to the process holding. So P1, A holds. So I do it like this. Okay. And request an instance of V. I'm requesting, so I draw it this way. Okay. Can Now I change to another color of orange. Now we look into the next one, which is P2. Okay. P2 is here. P2 holds an instance of B. P2 is here, B is here, so P2 is holding B. Okay, make sure your how do I say, your arrow actually stick to the circle. I mean the thing that you draw lah. Okay, so over here P2 holds an instance of B, request for an instance of A. So request A, so I do it like this. Macam ini. Okay, you don't draw cha like me lah, because it's a bit hard for me to control my toolkit. That's why I draw it this way. Okay, so the orange done. The next one, let me choose yellow lah. Okay, now P3, it holds an instance of A. So holding here, request an instance of C. Request not holding request okay. And the last one P4, simple and so direct. So I put it blue lah. Okay, so the last one, P4 holds an instance of C, which means C is currently held by P4, induced by P4. Okay, this one you finish already. Okay, make sure you draw it right. You better check one more time or 2 more time and so on. But make sure you have enough time as well because this one done already and you are good to go. Go to where? Not go to the next question. Go to justify. Okay, if you see your question asks you to justify, is there any deadlock? I mean, I want to keep it simple, so I just write it here. Justify. Lock also write wrong. Damn. Okay. Justify deadlock. So you have to understand this diagram, the one that you have drawn. Is there any deadlock? So now let me explain to you how to see is there any deadlock. You go one by one and see. There's 4 process. Is it able for the CPU to finish these 4 processes? Okay, I explain based on this question. So you see process 4 is holding this C, right? Which means process 4 is owning the resource C. All it takes is just the time to complete the process because these resources is already used by process 4. So as long as the process 4 is done done execution, then this resources C will be released, right? Okay, so in that case, you look at here, we can say that, this process 4 holding C, so maybe it takes 15 minutes for this process to done using the C. So we can actually say that, okay, in this case, process 4 can be executed first, right? Okay, it's able to execute. Now, you might wonder, okay, for those that you're not familiar with, you might wonder, why not process 1? There's 1, 2, 3, 4. Why should I go with process 4? You look at here, process 1, I am holding resources A, but at the same time, I'm requesting the resource B. Okay, holding resource A, requesting for where am I about to say process? Holding resource A and requesting for resource B. Now B is in use by process 2, right? So P1 have to be wait or have to be queue, right? So you cannot complete the process 1 first. Now you go to process 2. Process 2 is requesting for for resources A, and resources A is fully occupied as well. There's no A for this process 2 to use. But at the same time, process 2 is holding a resources B. I'm holding B, but I'm requesting for A, and there's no available A that I can use. So which means I have to wait as well. Okay, now you go into process 3, okay, process 3 holding for resources A, and they try to request for C. Now C, I want to use C, but C is in use by process 4. I cannot get C. Even though I'm holding A, I still have to wait for C to be available. So you see, process 1, process 2, and process 3, they are not able to execute, right? So I look at process 4. Is process 4 able to execute? Oh, holding C, maybe after a few minutes after the process 4 done execution, then this resources C is being released, then I can use. Okay, if you, let's say, imagine this, imagine only, okay, you better don't speed my video 2 times, and then you cannot follow this one, okay. So imagine this, if the process 4 is actually requesting for B, and then you see there's no B available, okay, justify deadlock, you say, yes, there is deadlock. Because there is no one process that you can execute at the moment. If let's say the question comes out like this, your process 4 is requesting for B, holding for C request, circular wait already, that is deadlock. Okay, but if there's no this line, let me wrap it off. Okay, if there's no this line, let's see is there any deadlock. So how do we continue to track? We see whether all the process can be executed. Okay, so P4 can be executed first, right? So P4 done already. Let me see who can do next. So I'm wrap this off as well. Oh yeah, cannot wrap this off already. Later I cannot share answer with all of you. Actually can lah. You guys just watch back and then take a screenshot over there. Okay, now process 4 搞掂already. So the resource C is available. So you see, can I execute P3 next? Because process 3 holding A, then one C, okay lah, then I can go for process 3 lah. Because C is now available so which means this yellow line is going to come in and use the resource. So run. Process 3 done already. So I wrap this yellow line off as well. Okay, now you see there's only 2 process left, only 1 and 2. So you see, can I go with process 1? Okay, process 1 holding A, requesting for B, but this B is holding by process 2, and then not done yet, which means I cannot do process 1. What if I start with process 2? So process 2 holding B, and then request for A. A is available after the process 3 is done. So which means your B is going to execute. Your P2 is going to execute next. Holding a B and then requesting for A. Okay, now requested successfully already. So I'm able to use it. Okay, so process. So now your process 2 is done as well. Okay, the last one, your process 1. So process 1 holding A and requesting for B, because your process 2 that hold the resources B is done as well, right? So which means your process 1 can use the B as well. So now the process 1 is also done. So you see, if you are able to execute all of this process, there's no something you catch you halfway, you didn't stuck halfway, all the process is being done, you see, start from 4, then 3, then 2, then 1, which means you justify there is no deadlock. Okay, if you see the question 4 marks, you better don't just write these 2 sentences, God bless you. Okay, if you see the question is 4 marks or above, okay, or for safety purpose okay, you just say there's no deadlock, then you say this is because, I write a short form, you better not write this in your exam. This is because the process, okay, can be execute in a sequence of, and then you follow by this thing, okay? Or if you have your tutorial answer, I believe if you go and study, you will see that, okay, the CPU, you write something, the CPU first execute process 4, okay, later release the resource C, SOUCS, okay, the resources C that used by process 3 to execute. And then what happened next? You write. That's it. I believe as long as you can draw this thing correctly, accurately, you're able to detect this process to be executed accurately and completely. This last part of writing shouldn't be a big problem with you. Okay. So with that being said, if you can master this one, okay lah. I think you can sleep well already. The next one, banker's algorithm. Okay, let me pause the video as well, and then I continue later lah.